Now this will be example 8. Now a multi-disc clutch has to be designed, multi-disc now, yeah, has to be designed to transmit 75 kilowatt from an engine running at 2000 RPM, revolutions per minute. Now assuming that the pressure distribution is uniform and limited to 150 megapascal, and the inner and outer diameters of the lining are respectively 100 millimeter diameters, yeah, and 150 millimeter. So this is the inner and this is the outer diameter. Now, determine the necessary end thrust or the axial force and the necessary number of plates, taking the coefficient of friction as 0.25. Now, if this clutch after manufacture is used to transmit the power from a larger engine to a rotor which has a mass of 1150 kilograms and a radius of gyrations of 200 millimeter, determine the time required for this rotor to reach 1500 RPM from standstill, that means from rest. Now assume that the clutch is transmitting at maximum possible torque. Now these are the answers, okay? So let us just start the question. Just working out the question, yeah? So these are the given data, the speed M1, the speed N2, the moment of inertia, the external diameter to radius, the internal diameter to its radius, the actual pressure, the coefficient of friction, and the power. So power transmitted under uniform pressure theory. So this is the power formula that we have. Okay, so the torque. So from this, we will be able to find out the torque because the question has given us the power and the speed. So what we need to do is from the power, we find the torque. And this will be the torque which to be transmitted by the clutch. So this is 358.1 Newton meter. So based on uniform pressure theory now, so we know that pressure equals to force over area. So the spring force will be equals to this. Remember, if it is the surface area here, the surface area of the clutch. This is a multi-disc clutch. Okay, for example, the force is 1472.6 kilonewton, the actual spring force. Okay, so this is the torque formula under uniform pressure theory. Okay, so I have worked it out here. Okay, without putting in the formula. So based on this, you will be able to find out the number of pairs of contact surfaces. So number of plates, we need to divide this by 2 because number of active or the number of pair of contact surface, okay, when you divide it by 2, you actually can be or would be able to find out the number of plates because each plate number of pair of contact surface is 2. Okay, actually we have another formula for multi-disc. Okay, so this is the original torque formula. So then from here you will be able to find out the actual spring force once we have, okay, round up number of pair of contact surface to be 16. Okay, so maybe earlier what you have found, you have decimal places, but then now you have to round it up because the number of pair of contact surface, the surface is a whole number. It's not decimal or it's not fractional. So you have to round it up to be a whole number. So let's say it's 16. So once you have round up this figure here, definitely the spring force here will be changed. So that is why we recalculate the actual spring force. Okay, and the time required for the rotor to reach another speed, 1000 RPM, 1500 RPM from standstill. So what we need to do again, the second law. Okay, find out the angular acceleration. This is the moment inertia that is given. This is the torque transmitted under uniform pressure theory. So that will be your angular acceleration. So once you got your angular acceleration and we know that the speed is on 1500 RPM, so which you need to times with 2 pi over 60 and changing the t to be the subject. Okay, so you will be able to find out the time, which is 20.2 seconds. Thank you very much. Stay safe and see you all soon.